Okay, so before we go into Chapter 2, exploring data with tables and graphs, I'd like to do a quick recap. Remember last week we talked about parameter and statistic. A parameter is a measure of a population, and a statistic is some measure of a sample. We talked about the levels of measurement. Nominal are those that name, where 1 is equal to male, 2 is equal to female, for example. Ordinal follow a logical order. Interval is when 0 is just a placeholder, as in temperature, and ratio is when 0 is the absence of something. We talked about discrete data, like live births and deaths. You can't have half of a live birth, so these are whole numbers, and continuous data are numbers that can be divided. So height, for example, or weight, 5 foot 3 inches. We looked at the different sampling techniques, simple random sample to cluster sampling to stratified random sampling. We talked about convenient sampling. We looked at types of experiments, cross-sectional, retrospective or longitudinal or cohort studies, and prospective studies. Cross-sectional look at a point in time. Retrospective, they're also called longitudinal or cohort studies, look into the past, and prospective studies look into the future. We also talked about confounding, things that make a finding of a study not clear, which can be alleviated with good study design and minimizing error. In this chapter, we're going to talk about different characteristics of data, measures of center, variation, distribution, outliers, and time. So when I get a data set, one of the first things I do is start looking at visualizing the data. So I can look at frequencies and percentages, and then I can create different graphs and charts in order to see how much of one thing or another we have. So what we're going to talk about here is frequency distributions and summarizing our data. So we're going to talk about the ability to summarize data in a frequency distribution and a relative frequency distribution. And we're going to identify values of class, width, midpoint, limits, etc., and boundaries. Frequency distributions help us understand the nature and the distribution of the data in our data set. A frequency table shows us how data are partitioned among several categories that are called classes by listing the categories along with the number, the frequency of observations in each category. This is easier to see than to read about. So, for example, on the left-hand side we have the class, and on the right-hand side we have the frequency. I also have the letter X because it could be any variable that we're talking about. Here we're talking about IQ score. Now, this particular data set starts with the number 50 and goes to 69 because there are very few people with IQ scores as low as 0, 1, and 2, and 3, all the way up to 50. So likely, if we had started counting each individual number, each individual IQ score, we would have a bunch of zeros in our right-hand column, because there'd be 0 people with 0 IQ, 0 people with 1 IQ, the IQ of 1 rather, 0 with the IQ of 2, etc., all the way up to 50 to 69. We have 2 people with that IQ. We have 33 with 70 to 89 as their IQ, and so forth. You can see that the hump is somewhere between these two numbers. So I would imagine that the median or the mean fall somewhere in between. Actually, the median, if I could do this really quickly in my head, well, we'd have to have a list of all the numbers, but the mean would be somewhere in between these two. So that's when the data are quantitative. We can also do it with qualitative or categorical data, right? Nominal data. If I sent this out to a survey asking people what's your favorite type of recreational activity, 26,212 selected bicycling and 25,376 picked football. We can display this in a table, or we can also graph it out. Right now, this is called a frequency distribution. This is the class is X and the frequency is F, the frequency of X. So we have a relative frequency is called a percentage of a frequency distribution when each class is replaced by the relative frequency or proportion or a percentage. We most frequently use a percentage. So if I take the frequency for the class, divide it by the sum of all the frequencies, and multiply it by 100, I'll get the percentage of people in that class. This is a very complicated way of saying what we already know how to do. The cumulative frequency distribution is the frequency for each class, and it's the sum of the frequencies for that class and all the previous classes. I'll make this clear in just a second when I show it to you in an SPSS output table. So in SPSS, I showed you how to make a histogram, and it starts the same way as making a frequency distribution. So what we do is we go into Analyze, which is where most of the things that we're going to do in SPSS start. So if you get to a point you're not sure what to do, just start clicking in Analyze, and you might remember, because most everything we're going to do is in Analyze. So you go to Analyze, come down and highlight Descriptive Statistics, slide over, highlight Frequencies, let go, and this box will pop up. You'll see your list of variables. This is from a data set I already have. I selected gender and clicked the button, and it popped over here. This is auto-populated, this check mark, and I just said OK. Click that button and you get this output. Okay, so the frequency, these are just the counts. We have 437 females, 443 males, and here's the total. All right, so the relative frequency is how many females out of the total right here, the total of everyone, including those who are missing. So that's 42%, but that's not really helpful, because that's what I'm interested in is how many people actually I have scores for. So I go to the valid percent. And then cumulative percent, I'll explain in just a second. So here's the relative frequency. When I'm reporting my data, I want to use the valid percent because it tells me actually how many people for whom I have data. The cumulative percent, look at this one. It says 49.7 females and then 100% male. That doesn't sound right, but what it's doing actually is it's taking 49.7, adding to this and reporting, yep, now we're at the sum of all the percents that we have. So